Kara Doran, and welcome to the St. Petersburg Science Festival. Our speaker during this session is Urmila, joining us from Mosi, the Museum of Science and Industry in Tampa. She is going to be talking about some space activities, talking about technology and how we understand worlds beyond our own. The answers are out there. Let's discover them together. Welcome, Urmila, and your Mosi scientist.
Hey everyone, my name is Urmila and I'm from Mosi. We're the Museum of Science and Industry. Hopefully you've been here to visit us, but since that's a little bit hard right now, we decided to participate in this amazing virtual St. Pete Science Festival and bring some amazing space activities to you. So we have Miss Catherine and Mr. Steven who are going to be doing a few activities about solar telescopes. We're going to launch a rocket, and then we're also going to look at some different sizes of planets. So if you're ready, I'm going to hand it off to Mr. Steven and Miss Catherine. Take it away, guys.
Hi everyone, my name is Catherine, joining you from Mosi, and today our lesson is going to be all about space and space exploration. Now, human beings have been wondering about space for thousands of years, and we've used our eyes to look up at the sky, and we've noticed some different patterns. And throughout history, people have used those patterns to determine what time of year it is, when it's good to plant and harvest crops, for example, how to navigate our world, so star is, for example, and also forming constellations to tell stories and pass down culture. But we were really limited for a long time by just using our eyes to explore our universe. And that all changed when we started to invent some bigger and better technology. The first kind that I want to talk about is, of course, telescopes. Telescopes gave us a much better view of our solar system, our galaxy, and our universe. I have two telescopes behind me here, and the smaller one you see on the right is a refracting telescope. Now, both of these telescopes today are set up with special filters that allow me to look at the sun. A refracting telescope is just a kind of telescope that uses lenses to focus light. And this is actually the same type of telescope, if more advanced, that Galileo used in the early 1600s to prove that the Earth was not the center of the universe. It was, in fact, the sun. And right now, I've got a good view of the sun. I don't know if you guys are going to be able to see it as well. But Galileo was able to determine that the sun was the center of the universe. Kepler, a few years later, was able to look at these planets and stars in motion and determine how planets orbited in our solar system. Turns out it wasn't a circle, it was more of an ellipse. And then later on, Isaac Newton actually developed another type of telescope, like the one that you see here. This is a reflecting telescope. A reflecting telescope, instead of using lenses, uses mirrors to focus the light. And this kind of gives me a different view of the sun altogether. But still, you'll notice that this one is much bigger. So the bigger your telescope typically, the better the image you can get, the more light you're able to focus. Now, telescopes helped us a lot. They really helped us gain a better view of our solar system, but they are somewhat limited by the fact that here on Earth, we have an atmosphere. Now, the atmosphere, of course, all those gases around our planet can distort light. So it makes it a little hard to focus sometimes on an image, no matter how big of a telescope that you build. In addition to that, we have problems like light pollution, such as from our cities or cars, and that can kind of mess with the light we're trying to collect from further away in space. But eventually, we were able to send our telescopes out into orbit. And telescopes in space don't have those same limitations. They're not affected by the atmosphere or light pollution, and they can really get a much crisper image. The problem with space telescopes is that it's much harder to maintain them. They're very far away. Sending an astronaut to fix a problem with a telescope is very tough. And another big problem with telescopes being sent into space is that we really want a big telescope, right? And it's tough to fit a big telescope inside of a tiny, tiny rocket. Right now, we're using the Hubble telescope in space, but we're about to switch to an even bigger telescope called the James Webb telescope. And it's even bigger. And scientists came up with kind of a novel solution to fix this size problem. So here I have a little bit of a model rocket, and I'm going to show you kind of what they did. They had a giant telescope, doesn't fit in the rocket, and believe it or not, they used origami to figure out how to make it fit. So you can see that the telescope already is made up of a bunch of small panels, right? All those little hexagons. And those hexagons are coated in gold because gold is very good at detecting infrared light. And as we fold up that telescope, now I can make it fit inside of my rocket. But as we said, we're not going to have astronauts in space to necessarily assemble and unfold it. So scientists needed to develop some mechanisms to help unfurl it. And I'm going to do a very basic model of kind of how we would do that. So I'll cut some string here. Oops, if my scissors were a little sharper. There we go. Get a little more. And essentially, not string, but they have two different arms attached on either side, so that once they fold it up, just like we did before, and they put it in there, it'll blast off into space, and robotic gears will unfurl the entire telescope, just like that. And then we're able to collect a ton of light all at once, not impacted by that atmosphere or the light pollution. And so hopefully we'll be able to get even crisper, clear images from even further away. Now, the next thing I wanted to talk about is rockets themselves. Getting these things into space is no easy feat. In fact, our space program, and I have a rocket over here that I'm going to show you, really started developing during the late 60s. And that's, of course, when we sent a man to the moon. So we were able to send people into outer space, and even eventually sensors and robots, such as Curiosity on Mars, and learn more about the surface of each of our different planets. Now, shooting off a rocket like this one, let me show you the different components. We've got a few basic parts on our model here. So rockets are pretty simple, really. We've got our nose cone. It's kind of aerodynamic, helps cut through all that atmosphere. And then we've got our body here, the main part of our rocket, some fins for stabilization. Inside this particular rocket, I also have a streamer parachute thing that's going to be my recovery system. It's going to help me find my rocket again. Rockets are very expensive, so if it's possible to use them more than once, excellent. And your payload, or what you're carrying into space, maybe your expensive equipment and sensors, is going to be in the body as well. And down here, ooh, it's topped up a little bit, is our engine. And our engine contains fuel. And burning that fuel is going to release the chemical energy into physical force. And we're going to be able to shoot our rocket up. Now, every action has an equal and opposite reaction. So as the fire goes down, our rocket should go up. That's right. And don't forget, the heavier your rocket is, the more mass it has, the more force you are going to need to get it to move. So let's hook up our rocket now. I've got a little bit of an electric current that I'm going to send through it, and it's going to shoot off my little, it's going to light a fire right here and start burning all that fuel. So, let me make sure I have my goggles on for safety. And let's see if we can get it to shoot off. Want to stand a little further back? You good? Okay. 3, 2, 1. Do we have batteries? Oh. Woo! Beautiful. I heard it land. I didn't see it. So we're going to have to find that rocket a little later. And rockets are a very good example of Newton's 3 laws of motion. We talked about a few of them, right? So force equals mass times acceleration. The heavier your rocket is, the more force you're going to need to get it to move. For every action, there's an equal and opposite reaction. So when the flames go down, the rocket goes up. Okay. And of course, an object at rest tends to stay at rest, so it's not going to move until we actually have something to blast it off. And an object in motion is going to stay in motion until something else impacts it. So that's why most rockets have thrusters on them, because once they get into space, there's not really any air resistance. There's not really anything to stop our rocket. So we need to find a way to kind of control its motion. Fantastic. Okay. The other thing I wanted to talk to you guys about is a little bit more about our solar system. Some of the things we've learned thanks to these amazing tools like telescopes and rockets. Do you know all of the planets in our solar system? Do you have an idea of kind of the size difference between them? Well, let's start off with the first thing. Our sun is the center of our solar system. And today, I'm going to represent our sun with this giant pumpkin. Okay, there we go, right at the beginning. And what's our next planet? Do you guys know? Our next planet is Mercury. Mercury is named for the Roman messenger god. And in compared to our pumpkin, Mercury is the size of a single seed. A little bean there. Very, very different. It's the closest planet to the sun. And believe it or not, Mercury has no tilt. So as it spins very, very slowly compared to Earth, it doesn't actually have any seasons because there's no tilt and no change in the amount of light that it gets throughout the year. And speaking of years, a year on Mercury is only 88 days on Earth. And that's because it's orbiting so much closer to the sun, it doesn't take as much time. But I mentioned it's spinning very slowly. That's because of that, a single day on Mercury is the same as 187 days on Earth. Pretty crazy. Do you know what the next planet is? Venus. So Venus is actually the size of a single cherry tomato. Okay. Venus, named for the goddess of love. Next planet, Earth. Earth is actually the densest planet in the solar system. Very similar in size to Venus, also a cherry tomato. And next, we have Mars. Oh no, it's a little windy. Mars is a tiny bit smaller than Earth, about the size of a blueberry. And all of these first 4 planets are what we call rocky. So they're made mostly of rock, they're dense, they're pretty small. But that changes when we get past the asteroid belt into the planet Jupiter. Jupiter is named for the king of the gods, and that's because it is our biggest planet. It is made of gas. Perhaps you've seen the storm kind of centered on Jupiter. That storm has been raging for hundreds of years. And then we have Saturn. Saturn, named for the god of agriculture, in our scale here would be kind of the size of an apple, smaller than Jupiter, but still extremely big. Did you know that Saturn is spinning so fast, it's not a perfect circle? It's squished. Then, only 2 left. We have Uranus, which would be the size, whoops, I think I got these sorted. Uranus is our little line there. And then Neptune, our furthest planet away, would be a little smaller than that. All four of our next planets are what we call gas giants. They're huge, but they're not very dense. They're mostly made up of different kinds of gases. In fact, Saturn is so light, so not dense, that if you had a big enough pool, it could float on water. So I wanted to give you guys kind of an idea of how spaced out these planets are in our solar system. So I'm going to gather these up, and we are going to space them about as far as they would be in our solar system. So starting over here, we have the Sun. Fantastic. And then Mercury, our next little planet right here, with those very long days. And then we have, of course, Venus. Venus is actually the hottest planet. You might think it would be Mercury because it's closest to the sun, but Venus has a runaway greenhouse gas effect. And so it traps the heat in its atmosphere and stays very, very hot. Then we have Earth, roughly the same size as Venus, nice and habitable. It is the only planet that has plate tectonics. Finally, Mars, the last of our rocky planets. Mars is red because of the iron oxide found in its soil. And if you're trying to remember the order of the planets, there's a mnemonic memory trick to help you remember called My Very Educated Mother Just Served Us Nachos. So Mercury, Venus, Earth, Mars. I think this was Saturn. Nope, Jupiter, sorry. There we go. And Jupiter is actually made mostly of hydrogen gas. That means if you brought a match onto Jupiter, you would set the whole thing on fire. Okay. Saturn. Did you know that Saturn has storms on its poles that are actually in the shape of a hexagon? It looks pretty crazy. And then going all the way over here, even further away, we have two planets left, two gas giants. Uranus, named for the god of the skies. And then further along, we're going to have our final planet. Now, we don't consider Pluto to be a planet anymore, call it a dwarf planet. There's a lot of little rocky things out far in the edge of our universe that kind of are similar to Pluto. But we're going to count Neptune as our last one. Of course, the god of the sea. And that's that. I hope that helps you remember some of the planets in our solar system a little better. I'm going to join you inside in 1 second to answer some of your questions. So we will be right back.
Hello, everyone. Thanks for watching. And I hope that you learned a little bit more about how we use telescopes, rockets, to explore our solar system, and as well as some more things about the size and scale of the planets in our solar system. If you have any of these fruits or any kind of toys at home that are about the same size, you can try this activity at home or in your backyard or with a grown-up's permission in your neighborhood. We hope you're able to do that. So right now, if anyone has any questions, the Mosi team would be happy to answer some of those questions for you.
Thank you, Urmila and Mosi team. We have a lot of questions, so we'll try to get through all of them before our time is up. But if we don't, maybe we can connect you with the students who are asking the questions. So we have Midtown Academy. They're asking a lot of questions. They must really like space. I'll let you answer this one. What gave you an interest to study science?
Oh, so actually all three of us can do this. For me, I always loved science as a kid. And one of the biggest things was having a role model. So when I was younger, my grandmother studied science. And then I used to watch Bill Nye the Science Guy on TV. And doing fun experiments in school really got me into science. So I'm going to let Ms. Catherine answer next. What got you into science, Ms. Catherine?
Hi, guys. Yeah, great question. I am just interested in all of the science, really. That's why it's so great that I get to work at a science museum, because I like, blowing things up in chemistry class. I like looking through the telescopes and learning all about astronomy. So really, I guess I was just always someone with a lot of questions. So if you're someone with a lot of questions, science lets you really explore and figure out more about the world around you. And so I really enjoy doing that. Mr. Steven?
Okay. Hello. So for me, I have a little bit different than our other two. I was always interested in animals. I am a zoologist, so I've been a zookeeper, and then I work at Mosi as well. So I've always just been interested in animals, especially living here in Florida. We're surrounded by the ocean and have some really cool forests here. So that's just something I've always been interested in. And that's kind of how I fell in love with it, is learning about why animals are the way they are and things like that. And of course, I do also like what Catherine said, looking through telescopes and chemistry and biology. But yeah, that was my thing. I'll give it back to Catherine.
Great. These two questions kind of go together. Is there a type of telescope that makes it able to look at the sun, and why can looking at an eclipse hurt your eyes?
That's a good question. The sun, of course, has so much energy coming out of it all the time. It's radiating a lot of wavelengths that our eyes just can't handle safely. Even our skin, if you're outside in the sun too long, you might have gotten a sunburn before. So my telescopes that I had outside actually can look at both. They can look at the night sky and they can look at the sun, as long as I put a special filter on the top. And that filter is special because it takes out almost all of the rays of the sun, and it only lets a very, very little amount through so that it can protect my eyes. It's kind of like sunglasses, but to the max.
Okay, great. How about this one? I guess, what did you do to make the rocket go up? Alondra would like to know. And then Midtown Academy wants to know why Earth's gravity can't pull it down.
Good questions. Yes, I don't know if you were able to see on camera, but I had a detonator in my hand. So it's just a little, essentially takes some batteries and shoots some electricity through my wires that I had coming out of the rocket's engine. And those wires got so hot that they set off a little bit of the fuel inside of my rocket and set the whole thing on fire all at once. And because it was compressed in the body, all of the fire could only come out of the bottom and send it right up into the air. It does take a lot of energy to fight Earth's gravity. So if my rocket was not strong enough, it wouldn't have gone up. And you did see that in the end, it kind of fell down. So it didn't actually have enough force to leave Earth entirely.
Okay. Let's go over to some questions about planets. What is the temperature on Jupiter from Midtown Academy?
Ooh, off of the top of my head, I am not sure. I would have to look it up. Sorry about that. But usually temperature on gas giants varies depending on whether it is facing the sun or not. So it can get pretty hot during the day and pretty cool at night. One thing I will say about Jupiter is the wind speed is so fast that it's faster than most hurricanes here on Earth. So that's kind of a cool fact about Jupiter.
Wow, yeah, didn't know that. Bella wants to know, how did we find out about the planets?
Well, some of the planets we have been able to see just with our eyes. So for example, Mars and Venus, because they're comparatively very, very close, if you get up at the right time of night, you can actually see them in the sky. And right now, Mars, oh, and Mr. Steven just found, the temperature on Jupiter is very cold, minus 145 degrees Celsius, and that's negative 234 degrees Fahrenheit. But the inside of the planet, the core, can be very, very hot. So, sorry about that. Mars and Venus as I said, you can see from Earth. And Mars right now is actually very, very bright. So if you get up just after sunset right now and you look to the east in the sky, you'll maybe notice a star coming up that has a little bit of a red tint to it. That is actually not a star, but the planet Mars. Now, the other planets, some of them we could see, some of them we were able to determine that they probably existed before telescopes were invented because of math. So we were able to see like how some of the closer planets were being affected by the gravity of those bigger planets. But once we invented telescopes, that's actually the first time we were able to discover Neptune, for example. Before that, we didn't know it was a planet.
Well, thank you, Catherine, and all the Mosi staff. We're out of time for questions, but maybe we can connect you all later. A lot of great questions, and thank you for joining the St. Petersburg Science Festival.
Yeah, and if I could say one thing, since we're out of time on questions, if you do have more questions on our YouTube and Facebook page, we have videos you can access all about space and other science topics. So if you have more curiosity, go check us out there.
Great, thank you so much. And we'll be back live at 1 o'clock with our next speaker.
Awesome, thank you so much.